Hi everyone, so let's continue our previous lecture only. So we were solving the problems of K-maps. We have understood the basic concept. Now we are solving the problems. So let's solve this one. So 1, right? Then 5. 5 where it will come? 5 here. 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is our K-map. Very famous example. We have already seen it. If I make this quad will be redundant. Why so? Because this one element can go here, this one element can go here, this one element can go here, and this one element can go here. If I had already made this quad, then it would have been redundant because each of its element has been already clubbed with another one, right? Each of the element has been clubbed with another one, so this is simply redundant. There is no use of it. And here I will write down the words, that is a bar, b bar, a bar, b, a b, a b, a b bar. Here c bar, d bar, c bar, d, c d, c d bar. I am focusing on mean terms. That means I will write SOP, sum of product. What I will write? Sum of product. So how I will write sum of product? So first let's see this one. So here c bar d is constant, c bar d is completely constant, and a bar is constant. So a bar, c bar, d plus. Are you getting this? In this club, in this pair, c bar d is constant and a bar is constant. So a bar, c bar, d. What about this pair? In this pair, a bar b is constant. A bar b is constant because a bar b is constant here. And what else is constant? C is constant, right? Plus in this pair, cd is constant. Along with that, a is constant. So a, cd plus. What about this pair? Here ab is constant and c bar is constant. So ab, c bar, right? ab, c bar. So that's it. This is our SOP form. So this is how we need to solve. Let's solve more examples. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I write it right? And what I am focusing on? Max term. Max term means I will be focusing on zeros. Zeros means I will be focusing on POS. This would be a plus b and this would be c plus d. So first I will start with a plus b, then a plus b bar, then a bar plus b bar, then a bar plus b. This would be c plus d, c plus d bar, c bar plus d bar, c bar plus d. Okay. Let's check it again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So let's start making the pairs. So what do I see? First I will see the pair of 4. Can I see the pair of 4? Yes. These 4 are, this is the pair of 4. This is the toughest pair to see, but we have built the practice. So this is the pair of 4 we can see. Now I need to pair this one, this 0, this 0, this 0 and this 0. Can I make any other pair of 4? No. So this 0 can go here, this 0 can go here, this 0 can go here, and this 0 can go here. Do you see one thing here? What is that? The pair that you made, 0, 0, 0, 0, that is again redundant because each 0 is being paired. Each 0. In this pair, which zeros are coming? This one. This has been already paired. This 0 is coming. This has been already paired. This 0 is coming. This has been already paired. And this 0 is coming. This has already been paired. So this group is completely redundant, which we will not take. Why we are not taking? Because this is a redundant group. Each 0 has been already clubbed, right? So how I will write the form? So in this one, a plus c plus d. C plus d is constant, a is constant. So a plus c plus d. Into, in this pair, c bar is constant, a plus b is constant. A plus b plus c bar. In this pair, c bar plus d is constant and a bar is constant. So A bar plus C bar plus D bar. And in this pair, C is constant, A bar plus B is constant. A bar plus B plus C. So this is the POS form, minimized POS form. If you had taken this pair as well, then another term would have come that is of no use, right? So these kind of things you need to take care. Let's see this example. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, very random example it is. I have taken very random example actually, right? So don't think we are getting anything good from here, just very random. So 4 club I cannot see. Can I see 4 club? No. So this I have to club, and this I can club. Now this 0 I can club with this one as well and this downward as well. I can club with anything. Okay, this 0 I can club with that other 0 as well, right? This 0. This 0 but this 0 I can club downward as well. So one pair we need to choose. One pair. Okay, it's not that you will choose both of the pairs. One pair you need to choose. This 0 and this 0, because this has only this chance, this has only this chance. This pair will be there. This pair will be there. This pair has to be there. This 0 has 2 chances. This 0 has 2 chances. So there will be 2 outputs of y. There can be 2 outputs of y because this other 0 has 2 chances, right? This has this chance as well. So there can be 2 different expression of y. So from K map we can get 2 expression as well. Okay, here we are getting. But in both of the expression, the number of literal count will be same. What is the literal count here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Now we will write 2 expression, both will have the same literal count, right? So this is A plus B bar, this is A bar plus B bar, this is A bar plus B. C plus D, C plus D bar, C bar plus D bar, C bar plus D. Let's see this pair first. So A is constant plus C plus D bar. In this pair A plus B is constant, A plus B is constant and D bar is constant. A plus B plus D bar. Now let's talk about this particular pair. In this particular pair A bar plus B bar is constant, A bar plus B bar is constant, plus C bar is constant, C bar is constant. Let's talk about this pair. This pair, in this pair A bar plus B is constant, A bar plus B is constant plus C is constant. Okay, and what about this pair? There are 2 pairs, so let's take this pink one. If we take the pink one, so in pink one C plus D is constant, C plus D is constant, or let's take the green one first. So here A bar plus B bar is constant plus D is there. This is the same. Okay, let's check back again. A plus A is constant here, C plus D bar. For this one A plus B plus D bar. For this one A bar plus B bar plus C bar. For this one A bar plus B plus C, and for this one A bar plus B bar plus D. Okay, or what could be the expression? Or the expression could be, first 4 term will go as it is. First 4 terms will go as it is. But in the last term we will go with the pink one. So in the pink one A bar is constant and C plus D is constant. A bar plus C plus D. Okay, so note, using K map you can get 2 different reduced Boolean expression with the same literal count. With the same literal count. So in MSQ, these kind of questions can come, that both options you need to click. Which one is the reduced expression? So both are reduced expression only. Both options you need to click. Okay, so these kind of questions can come in MSQ. Right? Let's see more problems. Don't care is 3, 8, 10. So let's start. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, sorry, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now let's see. Let's check back again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We should always recheck, because if we mess it up, if we mess this one up, then whole question is wrong. So this should be filled with good amount of patience, right? Can I, using the don't care, can I make any pair of 4? I don't think I can make any pair of 4. So which are the best pair I can see? As per me, these will be the best pairs. 1, 2, and 3. That's it. Why should we consider any don't care as 1? So 3 pairs has to be there, because I don't think I can make any pair of 4. If I cannot make any pair of 4, that means I have to make a pair of 2. And if I have to make the pair of 2 and with the 6 element, then certainly 3 pair has to be there. So if 3 pairs are there, then why would we consider these don't care as anything? So let's not consider don't care. Okay, so 1, 1, 1, these 3 pairs are there. All don't cares are 0 here. Okay, so this is your A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C, D bar. So 3 pairs are there. And what is this? This is sum of product. So here B is constant, C bar, D bar is constant. B, C bar, D bar, B, C bar, D bar, plus here A bar, B, A bar, B plus D, and here A, B, C, A, B, C. Okay, this is why. What about this one? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the scene. Okay. Can I make a pair of 4? Yes, I can make 2 pairs of 4. What I can do here, I can go like this and this. That's it. Or I have one more chance. What is that? I have one more chance, that is, with the help of don't care, I make this block. Basically, I would take this 4 block and these two zeros will be paired with these two don't care. So again there are 2 only. Again there are 2 blocks only. One quad and another quad. Or I could have taken one quad and then this quad. This is what I would have done. One quad and another quad. All zeros are captured. Or I could have done one quad and then this quad. Sorry, one quad and then this quad. So there, here also there are 2 possibilities, because there are these don't cares. So if don't care, I can take as 0, 0. So this quad and this quad also I could have taken. So in both of the cases, 2 quads are coming. So both are reduced expression only. Both are reduced expression. So first write down the first one, that is, in this quad C is constant and this quad A is constant. And this is already written there. Okay. So in this quad A is constant, in this quad A is constant, and in this quad C is constant. So A plus C into, in this quad A plus B is constant. This could be one of the answer, or y is equals to a plus c, and in another quad here c bar is constant and b is constant, b plus c bar, right? B is constant and c bar is constant, so b plus c bar. This could be other answer. So both answers are correct. Okay, both are reduced expression, both are having the same literal count, so two possibilities are there. So you will be having the options, right? So you will check all the options. From options you can check the clubbing, right? You can check the clubbing with the help of options. So you will check which all possibilities are there in the examination. We will solve these kind of problems so that you don't get confused. Okay, so these possibilities were there. Now let's see this question. You are given n variable logical expression. In K map you have done grouping of 2 to the power k cells. What will be the literal count of that particular group? N is greater than k and k is a whole number. So what I can take? I can take n is equals to 3 and k is equals to 1. Because if I take n is equals to 2, if I take n is equals to 2 and k is equals to 1, then 2 minus 1 will be 1. This option will also be 1 and this option will also be 1. So both two options will match. So that I don't want. So intelligently I am taking n equals to 3 and k is equals to 1. That means 3 variable is there. And I am doing the grouping of 2 cells. 2 cells grouping. So basically this is the scene. There are 3 variables and the grouping of 2 cells I am doing. This is the grouping I am doing. So let's just say this is A, B, C. So this is B bar, C bar, B, C bar. So basically, what will be the literal count of that group? What will be the literal count? Y will be what? If I am doing this grouping, so Y will be what? B, C bar. So what is the literal count? Literal count is 2, right? So in which option you will get 2? 3 minus 1. That is equals to 3 minus 1, or you can say n minus k. So that is the correct answer. Okay, are you getting this point? Basically in n variable, if you do the grouping of 0, then the least count would be n minus 0. In n variable, if you do the grouping of 1, then it would be n minus 1. In n variable, if you do the grouping of 2 to the power 2, it would be n minus 2. And in n variable, if you do the grouping of 2 to the power k, it would be n minus k. The least count would be n minus k. This is cell grouping, and this is the variable. And variable are there. Cell grouping is of 1, 2, 4. In that manner, if we are going, so least count would be n minus 1, n minus k. So this you don't need to remember. We just took an example and then we solved it, right? So in any kind of variable, these kind of questions can come. I hope you have understood the problem. Let's understand it again. 3 variables were there. I assume that 2 cell grouping is there. So 2 cell grouping is there. So what will be the literal count? That would be BC bar. So literal count is 2, 1 and 2. So that is n minus k. Okay. K map for ABCD is given. Draw the K map for F bar. Let's just say, what is my F? F ABCD is summation M 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What will be F bar? F bar will be what? Just whatever that is not there, that will come here. So 0, 2, 4, 5, 6, 9, 11, 12 and 14, right? 0, 2, 4, 5, 6, 9, 11, 12, 14. So similarly, wherever you here, if I am not marking anything, that means here there is 0, right? Here all are 0. So wherever there were 0, there would be 1, and wherever there were 1, there would be 0. So 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1 1 0. So basically you can see 0 0 0 0 0 0 0, rest all are 1. So you don't need to do this thing, just take the inverted of each individual cell. Just I am taking the end of each individual cell, each respective cell. Okay, this is the respective cell of this one. So here I am taking the note of that. So this is what we need to do. Just take the note of each respective cell. Right? Let's see the next question. Map the logical expression. Did I miss anything? No. Map the logical expression in K maps and find the reduced logical expression. Okay. So this is our question. So A bar plus BC. This is the first one. That is A bar plus BC. A bar plus BC. So this is A bar. This is A. This would be A bar plus BC. What is this? This is SOP. So in SOP only I will denote. So B bar C bar, B bar C, BC, BC bar. Now let's see it. A bar plus BC. So here only A bar is constant. In how do you think only A bar will be constant? That means this has to be 1, this has to be 1, this has to be 1, this has to be 1. So mark all the cells where you can see A bar. So A bar I can see in all these cells. So this is how I marked it. Then I need BC. So mark all the cells where you can see BC. BC I can see in these two cells. So what will be the possible grouping? This grouping and this grouping. So this is already reduced. Already reduced. That means this will be reduced Boolean expression. Reduced Boolean expression. Already it is reduced. Okay. We cannot do further reducing. Let's see the second one. In second one, what they are asking? A bar plus AC. So this will be your A bar. This would be your A. B bar C bar, B bar C, BC, BC bar. A bar. Wherever you see A bar, mark all that as 1. Wherever you see AC, mark all that 1. A is here, okay, and C is here. A is in this complete one, and C is here and here. So what is the common part? These two are the common part. Are you getting this point? A is in the complete one and C are here. A bar plus AC. A bar plus AC. A bar is here and C is AC. That means A is completely here and C is only here. So what is the perfect grouping? This group, and they have done this grouping, but that is not the perfect one. The perfect grouping is this, because we can make a quad here. So what will be your reduced expression? Although I can see it would be A bar plus C only, but let's solve it from the key map. So in this particular quad, what is constant? Only A bar. And in this particular quad, what is constant? Only C, because A is changing and B is also changing. So A bar plus C. So this is the reduced Boolean expression. Okay, let's solve the next one. B bar C bar, B bar C, BC, BC bar. So I hope you are understanding how we are doing it. AC plus BC. Now this would be more interesting. AC plus BC. Okay. So wherever you can see A, here. Wherever you can see C, here. A here and C here. That means what is the common part? These are the common part. C I can see here and A I can see here. BC. Wherever you can see BC, this is the BC. That's it. So 1 and 1. What is the reduced expression? This would be there and this would be there. So if I choose this particular pair, so here A into C would come, and if I choose this particular pair, then B into C would come. So this is already reduced Boolean expression. We cannot reduce this Boolean expression further. So this is already reduced. Let's see the next one. That is A plus C into B plus C. So this is given in terms of product of sum. This is what? Product of sum. So what I will write here? A bar, B plus C bar, B bar plus C bar, B bar plus C, right? A plus C. So A you can see here and C you can see here. So what are the common part? These are the common part. B plus C you can see here. So what is the best possible pair? This one, and the other one would be this one, right? So again, this is also reduced Boolean expression, but this is how we can denote it. Yeah, so this is already reduced Boolean expression. Let's try it in with the 4 variable ABC plus CD plus ABD. 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 So this is your AB, this is your CD. So A bar, B bar. This is what? This is SOP only. A bar, B, AB, and AB bar. C bar, D bar, C bar, D, CD, and CD bar. AB, wherever you can see AB here. How you can see C? C is here and C is here. So ABC will be written here. Plus CD. CD is complete this row. CD, CD, and CD. ABD. AB you can see here and D you can see here. There you go. Okay. So this is also already reduced expression. Why is that so? Because this is the possible one. Then you cannot make a pair of 3. You can make only a pair of 2. Then again you need to make a pair of 2. And there are no redundant group. If you are thinking there is a redundant group, then you are thinking something wrong. There is no redundant group, right? So this is your reduced Boolean expression. This one is going into 3. This one is going into 3. But this one is alone. This one is alone. And these ones are alone. So there is no redundant group. So this is already reduced Boolean expression. You cannot reduce this one further. And what is this FD? That means this is don't care. Okay. This FD is don't care. So this I can copy because I will not be able to remember all this. So this was my don't care. Let's see if I can reduce it. This is AB, this is CD. So A bar, B bar, A bar, B, AB, AB bar, C bar, D bar, C bar, D, CD plus CD bar. This is not in perfect form, so I will make it perfect. So A bar, B bar, C plus A bar, B bar, C bar plus AB, CD plus A, B bar, D bar plus B bar, C, D bar. B bar, C, D bar. Let me check it again. A bar, B bar, C bar, A, B, C, D, A, B bar, D bar, B bar, C, D bar. Okay. What about this one? A bar, B, C bar, D, A bar, B, C, D bar plus A, C, D. Okay. Let's start now. A bar, B bar into C. A bar, B bar is here, and where I can see C? C I can see here only. C bar, D bar, C bar, D, C, D, C, D bar. Okay. A bar, B bar is here, and C I can see here. So this is done. A bar, B bar, C. A bar, B bar, C bar. A bar, B bar, C bar. C bar I can see here. Right? A, B, C, D. A, B, C, D. A, B, C, D. A, B bar, D bar. A, B bar, D bar. A, B bar, D bar. Right? A, B bar I can see here. D bar, D bar I can see here. B bar, C, D bar. So B bar, I can see in this one. First let's check C, D bar. C, D bar is this one, and B bar, I can see here. Are you getting this point? This is C bar, C, D bar. This is C, D bar. This is all C, D bar. And I need to check B bar. So B bar I can see here, B bar I can see here. So these two ones only come. So that has already been come, right? These ones have already been written. These ones are repeated twice. Are you getting this point? B bar, C, D bar. C, D bar is there, and B bar is there in these two. So these two are there. Okay. Now let's see don't care. A bar B, A bar B, C bar D, A bar B, C bar D, A bar B, C D bar, A bar B, C D bar, A C D, A C D. There you go. Okay, A C D. So now you need to reduce it. Wait a second. What did I do? Just okay. This is A C D. No, A C D. Here you can see A, and here you can see CD. But this is already 1, so this will be only don't here, because we know this is already 1. Why did I write it 1 here? I should not write 1 here. So let's make the pairs. So this is the one pair that I can make. If I assume this as 1, then this will be a good pair, right? If I don't assume this one, then what will happen? This can go here, right? But what about this one? This one will be alone. So to make that, let's do this thing. So there are only 3 pairs. So what will be a reduced expression? A bar B bar plus, for this one A bar B bar, because only A bar B bar is constant. What about this one? A C D plus, what about this one? Here D bar is constant, so A B bar D bar, A B bar D bar. Okay, so this is the reduced Boolean expression. Reduced Boolean expression. So this is how if any function is given, you can represent in that manner, and then you can find the reduced Boolean expression. So there were so many of terms, but we reduced it to these many variables only. Why it is important to reduce these variables? Because we have to implement that on a chip, and if we use the least hardware, then the cost will be minimum. That's why we are reducing it. This is the target. Why we are reducing it? So that our cost is minimum, right? K-maps for two logical expression f1 f2 is given. Perform the following operation: f1 dot f2, f1 plus f2, f1 xor f2, f1 xnor f2. So these operations you need to perform. So how will you perform it? So if I write A, this is 0, 1, 2, 3, 4, 5, 6. So f1 is minterm m1, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7. Yeah. And f2 is minterm m 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 4, 6. 0, 1, 4, 6. So this is f1 and f2. Now I can perform the following operation very easily. f1 dot f2. That means only the common one will come. Venn diagram is in my mind. A into B. So only common will come. So 1 and 6. f1 plus f2. f1 plus f2. I will tell you another method. f1 plus f2 means everything will come. f1 plus f2. So 0, 1, 4, 5, 6. f1 xor f2. So everything will come, but not the common one. So 1, 6 will not come. 1, 6 will not come. So 0, 4, 5. And f1 xnor f2. That would be 1, 2, 3, 6, 7. Apart from that, everything will come. Apart from here, everything will come. So this is the first way of solving it. This is the method 1, which we have covered here. But what if the K-map is very large? So what you will do? You will write down these things. This was very very easy K-map. That's why I could have solved it. But now let's just assume if it was very large, then how you would have done it. Okay, this is already there. Yeah. So what is my answer? What is my answer of f1 dot f2? What answer I am getting? That is 1 and 6. 1 and 6. 0, 1, 2, 3, 4, 5 and 6. This is the answer I am getting. So basically here there are 1, so rest all are 0 only, right? Rest all are 0 only. If I copy f1 and f2, what do you see here? If these are 1s, that means these all are 0. If I perform f1 dot f2, if I perform f1 dot f2, that means 0 into 1 will be 0. 1 into 1 will be, see the cell to cell operation. Cell to cell operation. 0 into 1 will be 0. 1 into 1 will be 1. 0 into 0 will be 0. 0 into 0 will be 0. 1 into 0 will be 0. 1 into 0 will be 0. 0 into 0 will be 0. 1 into 1 is 0. So cell to cell operation is being performed. So I will write, I should not write adjacent, cell to cell operation, or what I can say, yeah, cell to cell operation only I can say. Cell to cell operation is performed. Okay, so in all the questions you just need to perform cell to cell operation. So if I need to draw for f1 XOR f2, so what I will do? 0 XOR 1, 1. 1 XOR 1, 0. 0 XOR 0, 0. 0 XOR 0, 0. 0 XOR 1, 1. 1 XOR 0, 1. 0 XOR 0, 0. 1 XOR 1, 0. Right? So this is how I can frame the operation. So if I am doing f1 XOR f2, then simply 0 XOR 1, 1. 1 XOR 1, 0. 0 XOR 0, 0. 0 XOR 0, 0. 0 XOR 1, 1. 1 XOR 0, 1. 0 XOR 0, 0. 1 XOR 0, 0. So what we are getting? Summation m as, this was your A, B, C. Summation m as 0, 1, 2, 3, 4. Sorry. This would be 4, 5. 0, 4, 5. Were we getting the same answer? 0, 4, 5. Yes, we were getting the same answer. So this is how you need to perform. Okay. So cell to cell operation is there. Cell to cell operation is performed. So this is very, very important line. Cell to cell operation is performed. That would be the correct answer. Okay. So always you need to perform cell to cell operation. Let's see 5 variable K-map now. Okay. Very important concept. 5 variable K-map. So for 5 variable we need to make 32 cells, right? So if I make 32 cells on one grid only, that would be very typical. So 16 I have made here, 16 I have made here. For the 16 ones I have assumed A to be 0, and for another 16 one I have assumed A to be 1. So for all these grids A is 0. What BC value can take? 0, 0, 0, 1, 1, 1, 1, 0. What DE can take? 0, 0, 0, 1, 1, 1, 1, 0. Now tell me, what will be the value of this cell? The value of this cell will be, A is already 0, where A is MSB, A is MSB, and E is LSB. So what will be the value of this cell? A is already 0 here. So 0 and rest all are 0 only. 0, 0, 0, 0. So this would be 0. Right? What will be the value of this cell? A is 0 and rest all are, BC is 0 and D is 1. So this would be 1. What about this one? 0, BC is 0, D is 1, 1. So this would be 3. This would be 2. In that manner we will go. This would be 4 because A is 0, BC is 0, 1 and D is 0, 0. Right? So what that would be? 1, 2, 4. So that would be 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, sorry. Blunder I am doing here. Sorry. What is the blunder? 8 will come here, no? 8, 9, 10, 11. Why 8 will come here? Because A is already 0 and this is 1, 0, 0, 0. So this is 8 only. 8, 9, 10, 11. 8, 9, 10, 11. 12, 13, 14, 15. Now what about this one? Again this will take 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. What will be the number of this one? A is already 1 and B, C, D, E all are 0. So 1, 2, 4, 8, 16. So this would be 16. So this number would be 16. A is already 1 BC is 0, D is 0, E is 1. So 16 plus 1, 17. This would be 18, this would be 19. 20, 21, 22, 23. What about this number? What will be this number? 1, 1, 0, 0, 0. So 1, 2, 4, 8, 16. This would be 24. So this number would be 24, 25, 26, 27, 28, 29, 30, 31. So in that manner we will go, right? Okay then. Now can you tell me which all cells are adjacent? Just a question. It will not be used in our analysis. It will not be used. But I am asking you, 9 is adjacent to which all cells? Can you tell me that? 9 is adjacent to 13. 9 is adjacent to 8. 9 is adjacent to 11 as well. 9 is adjacent to 1 as well. That you know. 13, 8, 11 and 1. But 9 is adjacent to some other cell as well. Can you tell me which cell? 25. Why is that so? Let's check that out. This is your 9, right? How I can write 9? 0. From here only I am writing. A is 0, BC is 1, 0 and D is 0, 1. So this is 9. What about 25? 25. A is 1, BC is 1, 0 and D is 0, 1. So your 9 is 0, 1, 0, 1 and your 25 is 1, 1, 0, 0, 1. How many difference bit is there? Only one bit is different. These 4 bits are same. Only one bit is different. So in adjacent cell, there is difference of only one bit. So these two cells are adjacent cell. So corresponding cells are adjacent to each other. Okay. Corresponding cells are adjacent to each other. That means this cell is adjacent to this one. These are certainly adjacent. 9, 9, 1, 8, 11. 9 is adjacent to 8, 9 is adjacent to 11, 9 is adjacent to 1. But these cells are also adjacent. Let's just say 15 will be adjacent to 31. Right? 3 will be adjacent to 19. So these cells will also be adjacent. If I say this pair, so this pair will be adjacent to this pair. Right? These two pairs will also be adjacent. Or what I can see, that this particular pair will be adjacent to this particular pair. So these two pairs will also be adjacent, right? So although diagram is being a bit hazy, but you are understanding the concept. Although it will not be used, I will tell you a simple method how to solve the problems. But what if in one liner they are asking this question that 13 is the cell number 13 is adjacent to what? So 12, 9, 15, 5, but 29 as well. Okay, so this you need to take care. Let's solve the problem. Summation m is given, 3, 4, these values are given, and you need to write down the Boolean expression. So reduced Boolean expression you need to write down. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Let's make the best possible pairs. So is this the best possible pair? No. If you see smartly, there you go. This is the pair we are getting. Four here and 4 here. Are you getting this point? The same kind of pair we are getting here as well. This pair we are getting here. This is the pair we are getting here, this one, right? And in the other one, this is the pair we are getting. right? This pair. Okay, let's write down the numbers. So B bar, C bar, B bar, C, BC, BC bar, B bar, E bar, B bar, E, DE, DE bar, B bar, C bar, B bar, C, BC, BC bar, D bar, E bar, D bar, E, DE, DE bar. Let's solve for this one. Okay, here A is 0, that means A can be replaced with A bar, because this is what we are talking about, SOP, max term SOP, sorry, min term, not sorry, max term, min term. So for min term, if A is 0, that means A will be replaced with A bar, and if A is 1, it would be replaced with A. So let's look at A bar only. So if A bar is there, then which pairs we are getting? Here what is constant? C is constant, and in this one E bar is constant. So C E bar plus, in this one which is constant? D is constant, and here C bar is constant. So C bar D E. Let's check back again. A bar, for A bar, C E bar is constant. C, here C is constant and E bar is constant, C E bar. So from here we are getting A bar C E bar plus, for A bar C bar, in this one D is constant and C bar is constant. So C bar D E bar. Let's check for this A. So for A we are getting, wait a second, call is, yeah. So for A what is coming? C is constant and E bar is constant. So C E bar plus, here D bar E is constant and C bar is constant. So C bar D bar E, C bar D bar E. So here what you are getting? A C E bar plus C bar D bar E. So what is your final output Y? Addition of all this. So A bar C E bar plus A bar C bar D E. Here A is also there, plus A C E bar plus A C bar D bar E, right? Can you reduce it more? No, like, yeah, we can certainly reduce it. This term we can certainly reduce more, right? Because here A will come in common, sorry, C bar will come in common. So A plus A bar. From direct from here also we can reduce it, that I will tell you. But I was thinking about this term, can I reduce it more? C bar, no, D, C bar E if comes common, no, there is no other chance, yeah. So A bar C bar D E plus A C bar D E. So basically total Y is coming from here, total Y is coming as C E bar plus A bar C bar D E plus A C bar D E. A C bar D bar E. A bar. Yeah. Yeah. So now it is fine. A bar C bar D E. A. Yeah. Okay. So this is the final expression. Now from here, what did you get to know? That A and here C bar was coming common and A plus A bar would be 1. So that you did not write here. How would you understand this in the K map only? So what did I tell you? This cell and this cell is adjacent, right? So this pair, this is actually not a quad. This is a octet. Look, these are adjacent to each other, no? This is not a quad, this is a octet. This one is adjacent to this one. 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 So this is a complete octet where A is also changing. Here A is 0 and here A is 1. So here A is also changing. So A will not come in the final answer. So directly I could have written C E. Here C is constant and E bar is constant. So directly I would have written C E bar. So in that manner I could have done it. Okay. Are you getting this point? This is a octet, not quad. 4, 4, and these 4 are adjacent to each other. So that's why I could have directly written C E bar. But this is the method I usually go with, I will just write down a bar and then solve all this. Then I will write down a and then solve all this. But in this question, I could have directly seen that the same quad I am getting in on both of the side. That means that will make octave. And if that is making octet, that means a is also changing. So a bar or a will not come in answer. So only CE bar would come in final answer. So this I could have done. Now solve this problem. You need to draw the K-map. So try doing it on your own. I will have to pause the video because I have some work to do, and then I will come back and solve this particular problem. Okay. So did you attempt this question? So what we need to do? We need to plot. So let's do B bar C bar, B bar C, BC, BC bar, D bar E bar, D bar E, DE, DE bar. Here B bar C bar, B bar C, BC, BC bar, D bar E bar, D bar E, DE, DE bar. Okay. I need to plot. First one is this would be our A bar and this would be our A. So first one is A bar, B bar, D bar. So only in A bar we need to see, and B bar, D bar, B bar and D bar. So B bar is here, D bar is here, and this is there in A bar only. Now BCE, BCE, BC is here and E is here, BC is here and E is here. Wait a minute. Some A bar is here and B bar, D bar is here. B bar is there and D bar is there. Okay, yeah. BCE. So in now this BCE is there in A bar as well, and this BC is there in A as well, right? Because if you take BCE common, then A bar plus A would be 1. So this BCE is there in A bar and A both. So BC, this is BC and E, right? So similarly here as well. CDE bar, CDE bar, C is there in this one, and DE bar, this is your DE bar, DE bar, this is your DE bar, and this is your C. So similarly here as well, DE bar, and here there is C, right? A B D bar, A that means only here, and B D bar, this is your B and this is your D bar. So B D bar, right? So this is the way I can proceed. So can I find the reduced expression of this? So this quad I am getting, this quad I am getting here. Here I can get another quad, and this pair I can get here. This same pair I can get here as well, right? But the same quad I cannot get on this side. I can get this here. So here there is 3 pairs, here there is 3 pairs. So in that manner I can do my pairing and write down my final answer. Okay. So only one pair is common there. Only this one pair is common. Rest all nothing is common. So let's try writing down the final answer. So let's see. So what we will get for A bar, Y would be A bar, here B bar is there and here D bar is there, B bar D bar, plus this is only here as well, A bar is the element of 4, this is a pair of 2, and if I had made this pair, look, there is very interesting thing in this problem, very interesting thing. What is that? Let's remove everything and let's make the pair again. Okay, so one quad I can see and one quad I can see. 4 element, both are different. 2 element, total element will be 4, right? Now I need to pair these two and I need to pair these two. If I make this one, basically I need to pair these two and I need to pair this one, right? I need to pair this one. So if I make, because here I can see 4 elements. So if I make this one, then I am getting a pair of 4. Then another pair of 2 I have to make. Did you understand this point? Till this point everything is fine. 4, 1, 1 common. So this is a pair of 4, this is a pair of 4, this is a pair of 4. Total 3 pairs I have made till now. 1, 2, and these two are adjacent to each other. So total 3 pairs till now I have made. Now I need to pair this one and I need to pair these two ones. So what I can do, if I make this quad, then another pair I have made plus 1, and then if I make this pair, then another one, another clubbing I have done. So total clubbing is 5. Do you agree to this point? Total clubbing would have been 5. 1, 2, 3, 4 and 5. Agreeing? Now if I have been a bit smarter, then what I could have done? Here I would have done this pairing. Now the same pairing I can do here. If I do the same pairing, so previously I had done 1 pair, 2 pair and 3 pair. Now I just need to make, this is 1 pair only because these two are adjacent to each other. So 3 plus 1, only 4 pair will be there. So in 5 variable K-map, if I was making 4 variable if I was clubbing these 4s in one go, then I was making 5 pairs. But if I am clubbing these two and these two, then only 4 pairs are there. Everything is quad only. This is a quad, this is a quad, this is also a quad, and this is also a quad. So 4 quads I have made. So this was very interesting thing, and this will be the reduced expression only, because 4 pairs are there and 4 we will be getting. If I had made 5 pairs, then I will be getting 5 terms, and that will not be our reduced expression. We need to reduce it further, but 4 pairs are possible. So that way we can proceed. So you just need to know this thing, that these correspondings are adjacent to each other, so we can pair them up. So we can make a quad and only 1 pair would be there, otherwise I had to make 2 pairs. So that was very interesting thing in this problem, and this would be the reduced pair. So that is the final answer only, right? Let's go to the next question. This you can plot, but this I have written wrong here. Why so? Because this is a max term. Max term means I will think in terms of POS. So here I have to write B plus C, here I have to write D plus C. And what this will be denoted as? This will be denoted as A, this will be denoted as A bar. This is B plus C, B plus C bar, B bar plus C bar, B bar plus C, D plus E, D plus E bar, D bar plus E bar, D bar plus E bar plus D bar plus E. So D plus E, D plus E bar, D bar plus E bar, D bar plus E, B plus C, B plus C bar, B bar plus C bar, B bar plus C. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, sorry. This error I do a lot of time. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Sorry, 20, 21, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 28, 29, 30, 31. Let's check back again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. There you go. Okay. So here I will do the clubbing. So first I can see a quad here. these two and these two. Another quad I can see these two and these two, right? What else I can see? Another quad I can see. What is that? This and this. Now I can club these two together. Basically, this will be clubbed with this, although only one element is clubbed. No. What I can do is that, sorry. This can go like this, 2 and 2, 4. 4 element, 4 element, 4 element, and then this is also 4 element. Now what else I can do? This will be a 2 element, right? This has to be 2 element only, because there is no other option left. This has to go in this manner only, 2 element, and this has the option of being paired with this particular element. Right? So a lot of pairs are there. Let's try writing the final answer. So this chord and this chord is there. So here C bar is there plus D plus E bar. D plus E bar. A will not come. Why it will not come? A and A bar will not come. Why? Because it is there in A as well, it is there in A bar as well. So this pair and this pair is gone into these two. These two I am taking. So here what is constant? E bar is B bar C is constant. B bar plus C is constant, and then E bar is constant plus E bar is constant. Okay. In this one, B bar plus C plus D bar, right? Plus D bar. Because these are common to both of them. This is also common to both of them, this pair. So this pair is gone, this pair is gone, this pair is also gone, this pair is also gone. Now talking about this pair, that is also common, A is also common. What about this one? B, here C is constant and D bar plus E bar, C plus D bar plus E bar, right? So this pair and this pair is gone. Which one is left? This is left. So this is there only in A bar. So A bar plus what is constant here? B plus C bar. What else is constant here? Plus D bar. And what about this one? This is also common in both. So here B plus C bar is already constant and D bar plus E is also constant, right? So can I reduce it more? No. I guess this is the final answer. This is my reduced expression. That's it. But these kind of questions will take a lot of time, and there is 99.95% chance that this will not be coming in your examination. But this was a very good question where we had to see all the possible possibilities. Quad is coming here, quad is coming here, quad is coming here, this quad, and then this pair and this pair. So there were 2 pairs and 4 quads, 4 quads and 2 pairs. So this kind of question can come that after clubbing, what you are getting: 4 quad, 2 pair, 4 pair, 2 quad, 1 single element, 2 pair, 3 quad. These kind of questions can come. So this was a good question. So that is the correct answer. Let's move towards the next one. So now we will see now five variable K-maps is completed. So this is the maximum limit that can come, although only one question has, or 1 or 2 question have come from 5 variable K-map. Okay, and you will be able to solve it with the concept that I have given. That is more than enough. So with that concept, you will be able to solve any problem of 5 variable K-map. Let's see the K-maps of XOR gate and XNOR gate, because there will be some kind of symmetry. Can you make the K-map for this one? A bar B, this is your XOR gate only, no? So A bar B plus A B bar, 0, 1. So in XOR gate, it will always start from 0 and 1, and alternatively you need to write 0, 1, 0, 1. And in XNOR gate, it will start from 1, 0, 1, 0. Alternatively, you need to write 1, 0, 1, 0. That's it. How will you remember if it is starting from 0, it would be XOR or XNOR? So you know one thing, that 0 XOR 0 will be 0 only. 0 XOR 0 XOR 0 any time will be 0. And first term, this term is always 0, 0, 0, 0, 0, 0, 0 only. So XOR gate will start from 0 onwards. Are you getting this point? This particular cell will always be in 2 variable, it will be 0, 0. In 3 variable, it will be 0, 0, 0. And in 4 variable, it will be 0, 0, 0, 0. In 5 variable, it will be 0, 0, 0, 0, 0. So always it is starting from 0 only. And if 0 XOR 0 you do any time, it will always give you 0. So XOR gate will start from 0, and alternatively you need to write 1, 0, 1, 0. Okay. What this will represent? Starting from 0, alternatively 0, 1, 0, 1, 0, 1, 0, 1 is written. That means this will represent A XOR B XOR C. But wait a minute. For 3 variables, XOR gate and XNOR gate are same. So this will represent this as well. What this will represent? It is starting from 1. So can I write down this thing? It will represent this. No, that is wrong, because both are same. So it will represent bar of this. I need to. Basically, if this is A XOR B XOR C, then these are the complemented form. This is simply the complemented form, no? So this is also simply a complemented form. This is also simply a complemented form only. 0 is replaced with 1, 1 is replaced with 0, 1 is replaced with 0, and 0 is replaced with 1. So this is also A XOR B bar, and A XOR B bar can be written as A XNOR B, but A XOR B XOR C bar cannot be written as, this is not equal, right? Both are the same thing. So this can be written as A XOR B XOR C bar. And if you remember one of our assignment, then I told you it can be written in this manner as well. It can be written in this manner as well. It can be written in a lot other manner as well, that B can come here, A XOR C. Basically, what I am doing, let's check. I will again tell it. So I am doing A, this is written as A XOR B XOR plus C. So can I assume it as X XOR Y, where X is A, Y is B XOR C, and whole bar is there. I told you one property, if a whole bar is there, you can take bar on one of the functions, right? Can I write it in this manner? Yes, you can write it in this manner. So this is X bar XOR Y. Can I write it as X bar Y XOR? And can I write this as X bar X XNOR Y? Yes. What is your X? A XNOR with B XOR C. Whatever the thing that you have done with, so from here you are getting this one. Whatever the thing that you have done with A, do the same with C. you will get this expression. Do the same with B, you will get this expression. Are you getting this point? So basically, this can travel anywhere. If there is bar on the whole one, then one of them can be replaced with dot, and this dot can travel anywhere. So this is the way you can remember it. Okay, what all other possible cases are there? I could have written as C XOR A, or I could have written C B XOR A, or I would have written because this is the other answer, so I would have written C XOR A, C XOR A XOR B. So A B C can be interchanged, and this bar and this plus and dot can move around. Okay, so they are moving around. So in that manner we can do. You can prove it as well. I have given the proof. Whole bar can be taken on one bar. Let's just say I prove this statement. So how I can prove this one? So can I write it in this manner? Bar is coming on 1 and then this. Now what is A plus B whole bar? That is this, right? And here is this one. So you can prove anything. Now here these two are inverted only. B is coming here, A is coming here. So both things are same only. Here also C and B are inverted. Basically anything can move around. You can prove this one. How will you prove this one? A XOR. Can I write it in this manner? Yes, you can write it in this manner. It would be A XOR. What is this? And now these two can move. C XOR B XOR with A. This you are getting. So on top level, how will you remember it? That one of them will be replaced with dot and one will be plus only, and then they can move around. That's it. This is how we will remember it. What about this? What this will represent? Starting from 0 and alternatively 1 0 are written. So this will be your A XOR B XOR C XOR D. What this will represent? Starting from 1, alternatively 0 are written. So this will be bar of this. And what is the bar of this? Since these are the 4 variables, that means even number of variables. So for even number of variables, this would be the condition, right? Let's see the next one. So K-map is shown. What this represents? Tell me. For A, this is your A bar and this is your A. So for A bar you are getting B XOR C XOR D XOR E, and for A also you are getting the same thing, B XOR C XOR D XOR E. So can I write it down in this manner? For A bar I am getting B XOR C XOR D XOR E, and for A I am getting B XOR C XOR D XOR E. So A I will take common. Yeah, so this is what I am getting. Okay, so I cannot take A as common. So what that would be? A bar, this I can write X bar into Y plus X into Y. This is the scene, right? So I can take this B XOR C XOR D XOR E common. That is being taken common, and here we are having A plus A bar, and A plus A bar will be 1. So what you are getting? B XOR C XOR D XOR E. So that would be the correct answer, right? Let's see the next one. If A is 1, A is 0. So if A is 1, what you are getting? This is B XOR C XOR D XOR E bar, right? Plus, if A is 0, that means A bar. So if A is 0, what you are getting? B XOR C XOR D XOR E. So this is X Y bar plus X bar Y. So that would be X XOR Y. So what is your X? X is A and Y is this. So what we are getting? A XOR B XOR C XOR D XOR E. right? X is A and Y is this one. So X Y bar plus X bar Y. So A XOR B XOR C XOR D XOR E. So this is what we are getting, and this is same as this one. Say yes or no? Both are same thing only, no? Because these are 5 variables. D XOR E. So 5 variables will be the same. So this is the same as this. Okay, so that is the answer we are getting. Okay, let's check this question. The same K-map is given, huh? The same K-map is given. But yeah, these 0 and 1s are replaced. So for A bar you are getting B XOR C XOR D XOR E bar, plus for A you are getting B XOR C XOR D XOR E. So this is X bar Y bar plus XY. That would be X dot Y. So that would be A dot B plus C plus D plus E. So this option is correct. What other option could be correct? Can I write this as A XOR B XOR C XOR D XOR E bar? How did I write it? Think about it and then only watch the solution. How did I write it? If I assume X, A as X, XOR, this is your complete Y, sorry, XNOR. So that can be written as this thing. So A is X, XOR B XOR C XOR D XOR E. Now what I can do? If this bar is there, then one of them will be replaced with the dot, and then that can move anywhere. Now this dot can move anywhere. So from here this option is correct, right? Along with that, what other thing can happen? That all the plus will be replaced with dot and one of them will be plus. This can also happen, that all of them will be replaced with dot and only one of them will be plus, and then this plus will keep on moving. So this plus is moving here, this plus is moving here. So all of them will be replaced with dot. How I am doing so, you can prove it on your own, right? What I am doing, A XOR B, and then whole bar I am taking on this one, B XOR C XOR D XOR E. So what is the bar of this? That is B XOR C XOR D XOR E. So all these plus are replaced with dot and one of them is plus. Other thing can also happen, all these are plus and this is dot. So in 3, 5, 7, 9, in odd number of variables, what you can do? Shall I write it? So all 4 options are correct. So from here, very interesting conclusion is there. First thing, for 2 variables, bar of this will be equals to A bar XOR B, right? Or it could be replaced as this. For 3 variables, these two are equal to each other, right? Bar of this, if I take bar of this, that means any of them can be replaced with dot and can move around. One is dot, one is plus, and it can move around. Between B and C is there, A and B is there, between A and C also it could be there. B can come in starting, then between A and C it could be there. So basically it can move around. For 4 variables, A XOR B XOR C XOR D bar will be equals to what? A XOR B XOR C XOR D. Anything else we can do here? Yeah, we can do more things here. What things we can do? That this is replaced with the bar and this is taken as one thing only, right? This is what I am doing. Now this can be replaced as right. This can also happen. Are you getting this point? Now can this bar keep on moving? Yes, this bar can also keep on moving. This is a bar. What else I can do here? That I do a plus b whole bar, and then c plus d is there as it is. So this could be c XOR d. Sorry. So a XOR b, and in between there is c, and then XOR d. So this dot can keep on moving here as well, right? And certainly bar of this is equals to a XOR, because b XOR c XOR d is equals to b XNOR c XNOR d. So this can be replaced with this, and these two can be alternative. Basically this and this are equal only, no? So this is what we are doing. This can also happen, right? Because a plus b bar if I take, and then so it would be x bar XOR y. So that can be replaced as x XNOR y. So this I have replaced. So these things can happen. So in MSQ these kind of questions can come up. So this is what I was trying to do here. Now can I replace 2 with the dot? No, that would be tough. 2 with dot we cannot replace. Basically what I was trying to do, a XOR b XOR c bar XOR with d. But bar of this will be what? Bar of this will be a XOR, bar of this will be one of this, a XOR b XOR c XOR d. This we have already got. So in this one, what did we get to know? That only one of the plus will be replaced with dot. These conclusion I am making here only. Okay, here only I am making these conclusions. Just we are playing with this bar thing, with XOR or XOR thing. So only you don't need to remember these conclusion. Okay, just I am telling if some question is coming in MSQ, because there are MSQ as well. So you need to check all 4 options. We don't want you to do that particular question wrong. So if a whole bar is there, one can be replaced with a dot, right? If whole bar is there, only one can be replaced with dot, and rest all will be the same. It cannot happen that 2 dots are there and 2 dots cannot be there, right? 2 dots cannot be there, because if 2 dots are there, then 2 bar will come. Yeah, that cannot happen. So 1 and 2, in that manner we can do. And for 5, that would be equal only. And if you take the bar, then what will happen? That we have already proved that all of them can be replaced with the dot, but one will be at least plus, right? These can be replaced with the plus only, but one of them can be dot, or this dot can keep on moving. Basically a XOR b XOR c XOR d XOR e, and then this plus can also keep on moving, a XOR b XOR c XOR d XOR e, and these variables can also keep on moving. So these kind of things can happen. Are you understanding why this is happening? Actually the thing is, if 3 dots are there, that means I can make 3 bars, and if 3 dots are there and I need to convert it into plus, that means I need to take 3 bar, 1 2 and 3, and if 3 bars are there, that means it will be replaced with 2 bars will cancel each other and single bar will be there. So this is only we are getting. Here also I replaced 1 dot, so basically I can take 1 bar. To convert this dot into plus, I can take 1 more bar. So if I convert this dot into plus, I will have to put 1 bar there. So the same thing I am getting. If I need to convert this dot into plus, that means I need to take 1 bar. If I need to convert this dot into plus, I need to take 1 more bar. If I need to convert this dot into plus, I need to take 1 more bar. So if I am taking 3 bar, that means 2 bars are cancelled and 1 bar is left. So this is the final conclusion. This is very interesting conclusion that we have come through. To convert a dot into plus, you just need to take a bar. That's it. To convert this dot into plus, I just need to take a bar. So what I will be getting? This expression only. To convert this dot into plus, I need to take 1 bar, 2 bar and 3 bar because there are 3 dots. So this is an interesting conclusion, right? So from options we can check in this manner that there are 3 dots. That means I need to take 3 bar to convert these dot into plus. So if I am taking 3 bar, then 2 bar are getting cancelled and 1 bar is there. So eventually I am getting this expression only, or this expression. Basically I can write this as this expression. So eventually I am getting this expression only, right? So similar thing goes here. There are three dots, so 3 bar will be there. To convert that into plus, there is 1 dot, so 1 bar will be there. So to convert that into plus, so same expression we are getting. There is 1 dot, so 1 bar. So this is the interesting conclusion, very interesting conclusion. What did you understand? So one more thing I will write. Let's write down a question only. Question: y is equals to a XOR b XOR c XOR d XOR e XOR f XOR g 3 3 6 7 will be equivalent to option A XOR b XOR c XOR d XOR e XOR f XOR g whole bar. B A XOR b XOR c XOR d XOR e XOR f XOR g. C option, what I can write? A XOR b c d e f and g. And D option I am writing A XOR b XOR c XOR d XOR e XOR f and XOR g. All these are XOR only. So which of these options are correct? What do you think? Which is your correct answer? 1, 2 and 3. Why is that so? Because there are 3 bars. If you need to convert these 3 bar into 1 dot is converted to plus, this dot is connected to plus, this dot is connected to plus. So if I convert all these to plus, that means 3 dots I converted to plus. So 3 bars I will have to take. 1 bar, 2 bar and 3 bar. So if I am taking 3 bar, then these 2 bars are getting cancelled. So finally I am getting A XOR B XOR C XOR D XOR E XOR F XOR G bar. So this is matching with option 1, right? If I go with the option B, so in option B 1, 2, 3, 4, 5 dots are there. If I need to convert these dots into plus, so I will need to take 5 bars. I will need to take 5 bars. So 1, 2, 3, 4 and 5. I am taking 5 bar, 4 of them are getting cancelled. So basically A XOR B XOR C XOR D XOR E XOR F XOR G. So this is equivalent to this only, right? And for the C1 only 1 bar I need to take. So A XOR B XOR C, XOR D, XOR E, XOR F, XOR G. So only one dot is there, so only one bar I need to take. So this is also equivalent. In D, how many dots are there? How many dots are there? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 dots are there. That means I will take 6 bar. And if I am taking 6 bar, that means this will be equivalent to A XOR B XOR C. 6 bar means same only. D XOR E XOR F XOR G. So it will be coming out to be same only, because if I am taking 6 bar, it is coming out to be same. 6 bar will cancel each other. 2 cancel each other, 2 cancel each other, 2 cancel each other. So this is coming out to be this, but this is the bar of that. So if there is bar of that, that means both are different thing. So that is our correct answer, A, B and C. So in that manner we can solve. So yeah, a lot of new things we got to understand in this lecture. We got to understand about 5 variable K-maps. We got to understand how to plot them in K-maps, how to write down the reduced expression. So these 2 lectures are there, would be of around 2.5 hours. Now we are going to study about implicants, prime implicant, essential prime implicants, redundant prime implicants, selective prime implicants. These implicants we are going to study in the next lecture. So let's meet you in the next lecture.